Right, so we come to the second part of the potential divider. Okay, so just now we are talking about in the previous video we're talking about the series of resistors that give you that construct the potential divider. So now we move on to an extension to that is we need a lot of resistors. Okay, so because we want to divide the battery into many parts so that we can change its PD that we want. We can change the PD that we want at any smaller value, not just 6 volt, but we want to also get 0.5, 1, 1.5, 2.5 and all that. So in that sense, connecting many resistors in a series become very difficult. Okay, because you need many resistors. So in order to solve that problem, now we use length of wires instead. Okay, length of resistant wire. Okay, so that's what this diagram is trying to show you. This one is basically the one at the top here basically is the standard symbol for a potentiometer, or we call variable resistors. Okay, potentiometer or variable resistors. Okay, it's about the same. Okay, but when we draw, right, we usually draw the bottom one to illustrate what is actually happening. So that's when we have the wires, uniform resistance wire connected across A and B, and then we have a sliding contact. Okay, so that's like the lamp earlier in the previous picture. So that lamp will be connected across here. So as you move the slider up and down across AB along the wire, you get a different voltage for your lamp. Alright, because the ratio of this can be vary continuously. So that's basically the R1 here. R2 is on the other part. Okay, so usually this part of the topic will come up with some complicated questions that you need to analyze that very carefully, and usually you need to your answer will be based on the understanding of potential difference that you want to get is proportional to the length of the wire. Okay, so let's say we go back to the case just now. We have 12 volts here, and your lamp you want the 6 volts. So logically, things that make sense is that you will divide the length of the wire into 2, and then you connect the contact in the middle, right? So that will be making sense. You connect it at the middle, then you get half. You connect it at 1/4, then you get quarter of the voltage. Half, you get half of the voltage. 3/4, you get 3/4 of the voltage. You connect across the whole AB, you get the full 12 volt. Okay, so that's basically based on the potential difference is directly proportional to the length. But the thing is, you also need to understand how this relationship is derived. So actually it comes from the equation of resistance is rho L over A. So rho L over A. So now we further expand the resistance into PD across the resistance R1. V over I equals to rho L over A. So remember, it's a uniform resistant wire. Means that the A must be very consistent. The rho, the resistivity, because the same wire, resistivity is the same. Because this wire is in series with the battery, so it's the same current across every part of it. Therefore, at the end, we can deduce that the PD across any length of the part is directly proportional to its length. Okay, it's directly proportional to its length. Alright, so in the next video, I'm going to explain one example. It will take quite long, so that's why I push it to the next. Alright.